I'm repeating this, and this is the alpha particle, and this alpha particle is moving very nearer to the charged nucleus. Then when it goes very nearer to the charged nucleus and deviates its path. Deviation means what we consider here? Deviation is nothing but it moves away from its original direction. Original direction నుంచి deviate అయ్యింది. ప్రోటాన్ నెంబర్ ఆఫ్ ది టార్గెట్ న్యూక్లియస్ ఏంటమ్మా ఇక్కడ Z అని తీసుకుంటే దాని యొక్క చార్జ్ Ze అవుతుంది. ఇక్కడ వచ్చినప్పటికి ఏమవుతుంది? ఆల్ఫా పార్టికల్ is nothing but positively ionized helium, and this is nothing but 2 is the proton number 2e. At that point where it deviates, at that particular point, according to law of conservation of energy, kinetic energy is converted into potential energy. The movable particle is considered as kinetic energy, consisting of kinetic energy. Once at that particular point momentarily stops, and thereby it means what? Kinetic energy is converted into potential energy. Potential energy is nothing but, in the lesson electrostatic potential, we get this value. In between the two charges q1 and q2, the separation is r. Then the potential energy is nothing but 1 by 4 pi epsilon naught q1 q2 by r. And here r is nothing but r naught. That is the distance of closest to approach with how close the particle is present to the target nucleus. Now with that, kinetic energy half mv square. This is the r naught. q1 is nothing but Ze, and q2 is nothing but 2e. And thereby here I required r naught, distance of closest to approach, and thereby r naught equal to 1 by 4 pi epsilon naught Ze into 2e by half mv square. Like this, this half mv square replaced with kinetic energy. In any problem, if you get the kinetic energy value, then substitute that kinetic energy value. Charge of electron 1.6 into 10 power minus 19 coulomb, and in the problem proton number is mentioned, that is Z. 1 by 4 pi epsilon naught is nothing but 9 into 10 power 9. If you substitute all these values in this problem, then we will get the distance of closest to approach of that particular topic. Okay, then. Fine. And now here, one more important topic in this is nothing but impact parameter. What's that? Impact parameter. So what about the impact parameter? So impact parameter is nothing but, here that is nothing but the perpendicular distance between the scattered particle, alpha particle, onto the nucleus. There is a perpendicular distance between the scattered alpha particle onto the nucleus. Then it means what? This is the alpha particle. This is moving in this direction. It's scattered like this. It deviates its path, scattered from the original path. Okay. So now, for example, one more alpha particle is taken here that is moving in this direction, and it's scattered in this direction. Scattered. So here this impact parameter is nothing but what? The perpendicular distance between the scattered particle and the nucleus. This is the one indication line, one reference line you consider like this. This is one reference line. From here, if the alpha particle scattered, so from this alpha particle, nothing but to this direction and the nucleus direction, and here we are taking that perpendicular distance. For example, this is one reference line. Along this line, nucleus is present. If the alpha particle is moving in this direction, in this alpha particle scattered like this. So to the scattered alpha particle and to the nucleus, whatever the perpendicular distance is present, that perpendicular distance we are naming as impact parameter. Okay. So what's the formula of impact parameter? Impact parameter. So the formula of impact parameter is nothing but B is equal to Z square cot theta by 2 by Z square cot theta by 2 by 4 pi epsilon naught into Z square cot theta by 2 by 4 pi epsilon naught into half mv square. Half mv square. So here mass is nothing but, m is nothing but mass of alpha particle, v velocity of alpha particle. This is the formula of impact parameter. So this impact parameter depends on scattering angle. Scattering angle. What is the meaning of scattering angle? For example, this is the actual direction. With the actual direction, how angle it can be deviated, how angle it can be scattered, that is the scattering angle. Theta is the scattering angle. Okay, like this we considered. And here also, this is the scattering angle, theta. Right? So this impact parameter depends on scattering angle. Remember this is one of the important point. Okay, so for example, here if the scattering angle decreases, theta value decreases. It means here I am taking the one form, B is directly proportional to what? That cot theta by 2. The scattering angle related to B proportional to cot theta by 2. Why? Because that is in the numerator. Okay, so now if theta value decreases, and then here if theta decreases, cot theta by 2 increases. If you go through with the trigonometric values, then theta decreases, cot theta by 2 increases. If cot theta by 2 increases, what is the relation between B and cot theta by 2? Directly proportional. If cot theta by 2 increases, B also, impact parameter also increases. Nothing but the perpendicular distance between the two, this value also increases. Okay, this is the one of the important point. Just remember this. Now, so from this here we are taking another point. If I'm considering that impact parameter is 0, this B value equal to 0. If B equal to 0. So if B equal to 0, what happens here? If B equal to 0, then this cot theta by 2, this entire term, if you take the cross multiplication, 0 into anything equal to 0, then cot theta by 2 are equal to 0. Cot theta by 2 equal to 0. Cot theta by 2 equal to 0, then when the cot value becomes 0, cot theta by 2 equal to cot 90. Cot 90 equal to 0. Then both sides remove the cot. Then theta by 2 equal to 90 degree. Then theta is equal to what? 180 degree. 180 degree means what? 180 degree means what? So just now previously I said one term that is, listen, one term that is, this is the target nucleus and this is the alpha particle. Some of the alpha particles are retraces back in the same direction. It means what? If one alpha particle is moving like this direction, then when it's close nearer to the nucleus, then what happens here? Positive charge can be repelled. So that alpha particle again moves in the same direction in the backward direction, retraces back. When it retraces back, at that moment we used to say that theta is equal to what's the value? 180 degree. Then there is no particular perpendicular distance. That's why the impact parameter is equal to 0. Impact parameter manam 0 ga తీసుకుంటాము. Okay, అర్థమైందమ్మా ఇది? So we used to say one word, very few alpha particles are retraces its path. Retraces means what? In whatever the way is moving, in the same way it is coming back. That's nothing but retraces, right? So this is one important concept related to the impact parameter as well as the distance of closest to approach. Okay, so whereas in case of Rutherford alpha scattering, here one thing is considered, one formula is considered, how many number of alpha particles are scattered per unit time. How many number of scattered per unit time. Okay, so it means what? In unit time, in 1 second, for example, in 1 second, how many number of alpha particles are deviating from their original path? Deviating from their original path. ఓకే, సో దానికి సంబంధించినటువంటి టాపిక్ మనం ఇక్కడ తీసుకుంటున్నాం. దానికి ఒక ఫార్ములా డిజైన్ చేశారు. ఆ ఫార్ములా ఏంటి అని అంటే చూడమ్మా, రైట్ డౌన్ నెంబర్ ఆఫ్ ఆల్ఫా పార్టికల్స్ స్కాటర్డ్ పర్ యూనిట్ టైం. Scattered per unit time is that we are mentioning with capital N. So capital N is equal to, here one formula is mentioned, and that formula write down ma, Q N T Z E square by Q N T Z E square by 4 epsilon 4 pi epsilon naught whole square, as well as R naught square E square sine power 4 theta by 2. This is the formula for that. Actually, for every term its own meaning is present. capital N is equal to number of alpha particles scattered per unit time. Okay, so Q N T Z square by 4 pi epsilon naught whole square R naught square E square into sine power 4 theta by 2. Then what about the Q, N, T? All these terms need to know. Okay, what about the Q? Write down. Q is equal to number of alpha particles incident. What is the meaning of incident? Where these are incidenting? Okay, so where? It means how many number of particles are alpha particles are moving towards the target nucleus. Moving towards the target nucleus. That's nothing but incident. Okay, Q is nothing but number of alpha particles incident. Then what about the N? N is nothing but number of atoms in gold foil. For example, whatever the gold foil is considered, for example, this is the one gold foil. In this gold foil, how many number of particles are present? How many number of particles are present? That is the N. And T is nothing but thickness of the gold foil. T is the thickness of the gold foil. And Z is equal to whatever the element we considered. For example, gold is one element, right? That atomic number we need to consider as Z. As you know that E is nothing but charge of electron. So 4 pi epsilon naught, as already you know that, and R naught. So here R naught is nothing but distance between the gold foil and the screen. Distance between the, simply you consider as R. So here a screen is present and here target nucleus is present. And from here alpha particles are moving towards the target nucleus, nothing but screen. And here moving towards the screen, scattering, different directions, different scattering takes place. So now all these scatterings are considered like this, and nothing but what is the meaning of that? The meaning of that is nothing but at every scattering, at every contact with this screen, scintillations can be observed. Scintillations nothing but small sparks can be observed. By measuring number of sparks here, we observe that okay, number of alpha particles are touching that screen, like that we can consider. ఓకే, సో ఇప్పుడు ఏంటి అంటే ఈ ఆర్ అంటే ఏంటి అంటే ఈ టార్గెట్ న్యూక్లియస్ కు అలాగే ఈ స్క్రీన్ కు మధ్య ఉన్నటువంటి డిస్టెన్స్, దట్ ఈస్ ఆర్. ఓకే, నౌ లిసన్ మా. మరి ఇక్కడ ఈ అంటే ఏంటి అని అంటే ఈ ఇస్ నథింగ్ బట్ కైనెటిక్ ఎనర్జీ ఆఫ్ ఆల్ఫా పార్టికల్. మెన్షన్ దట్ కైనెటిక్ ఎనర్జీ ఆఫ్ ది ఆల్ఫా పార్టికల్. Theta is nothing but angle of scattering. That also called as scattering angle. Okay, so ఇవన్నీ వాటి మెజర్మెంట్స్. మరి దీని నుంచి ఒక ఇంపార్టెంట్ n is inversely proportional to sin power 4 theta by 2. sin power 4 theta by 2. దీని మీద నెంబర్ ఆఫ్ మోడల్స్ కూడా మనకు ఉన్నాయమ్మా. So n is inversely proportional to sin power 4 theta by 2, and at the same time n is inversely proportional to kinetic energy square of the kinetic energy, E square. Why? Because this is the denominator. And then n is directly proportional to T, thickness of the foil. Okay, n is inversely proportional to distance between the target nucleus and the screen. N is inversely proportional to R square. Like this, different notations when be considered, different formula can be considered from this formula. Okay, got it? అర్థమైందమ్మా? అర్థమైందమ్మా? Fine. Okay, so now, and one more thing. Now from this here, we consider that another concept, that is Bode's theory. Okay, so నాకు ఏంటంటే Bode's theory అంతా, I mean I will tell the Bode's theory entire part in one class, then it can be easily understood by you, right?